everyone, Miss Sarah again. Here I am with material that is called Euclid's plate. Right now for this lesson, this first one, we're just going to use it to go over Pythagoras' theorem again. Oops, it's got a little stuck in transportation. Okay. So as you can see, it looks very similar to the plate that demonstrated Pythagorean's theorem, although we've got some extra parts here. So let's use this plate to prove Pythagoras' theorem. Okay? In another way, we're going to prove it. So let's take a look. Okay, we have our right-angled triangle here. Okay, and this one is also scaling. Okay, you can see that because all three sides are different, and the hypotenuse is obviously the longest. So we have two legs and a hypotenuse in our triangle, and we have the two squares coming off of the legs and our largest square coming off of the hypotenuse. I want to take a look at something here. Okay, so we want to see, if you remember, if this, in fact, plus this does equal the area of the square off of the hypotenuse. Well, let's look at something here. I'm going to remove the largest square here. I'm going to slide our triangle down. It's still in there. It's just down at the bottom now. I have my yellow parallelogram. I'm going to place that here. And my blue parallelogram, I'm going to place that here. So it looks like the yellow parallelogram plus the blue parallelogram, along with that right-angled triangle, takes up the same amount of space that the red square took up with the right-angled triangle. So you could say that the yellow parallelogram plus the blue parallelogram is equivalent to the space that the red square takes up. Okay, so these two are equivalent to this. Now I'm going to put those back. We're going to use that information to look at another piece. Well, let's look at something else here. If I remove the yellow square built off of the leg on this side, and I slide our right-angled triangle, watch this. This yellow parallelogram takes up the same amount of space as the yellow square. Oops. Slide that back. Well, let's see if the same holds true for the blue parallelogram and the blue square. We'll slide our right-angled triangle. Look at that. The blue parallelogram and the white right-angled triangle take up the same space that the blue square and the right-angled triangle took up. So that must mean the blue parallelogram is equivalent to our blue square. Oops. Slide that back. So let's think about what we just did here. We were showing that the square built off of the hypotenuse is equivalent to the yellow parallelogram plus the blue parallelogram. Well, since the yellow parallelogram is equivalent to the yellow square and the blue parallelogram is equivalent to the blue square, that means this square plus this square is equivalent to the square built off of the hypotenuse, which again shows that Pythagorean's theorem holds true for right-angled triangles like this one that are scalene. You might be wondering why this is important or related to the story about Euclid. Well, that is to come in another lesson using this plate.